Hello students, today we are going to study Standard 10th Science and Technology Part 1, Lesson number 4, Effects of Electric Current. In this chapter, some topics are there: energy transfer in an electric circuit, heating effect of electric current, magnetic effect of electric current, right hand thumb rule, magnetic field due to a current in a solenoid, force acting on current carrying conductor in a magnetic field, Fleming's left hand rule, electric motor, electromagnetic induction, Fleming's right hand rule, alternating current and direct current, electric generator. Now we will see one picture. You have to observe. And what do you observe in the following picture? Which effects of electric current do you find? Here in first picture, it is an interior part of a house. Here a ceiling fan is there and here doorbell is there. Now in our house some equipments are there: two lamps, one television and one heater. Here, which effects are there? In lamps, electricity is converted into light in both the lamps. Here, electricity is converted into sound, light and some amount of heat. Here, electricity is converted into light and heat. Then, in case of ceiling fan, electricity is converted into mechanical energy, and due to this mechanical energy, this ceiling fan runs. And here in doorbell, electric energy is converted into sound. Now, from these examples, you will be clear that the electricity is energy and we can convert it into many forms and use it. Now, let us consider this circuit. In this circuit, suppose in this place here, R is a resistance which can be replaced by any of our equipment. Suppose there is a bulb, electric bulb is there. Then if charge Q flows from A to B in time t, that is, the work is performed in time t, then during that time the energy will be VAB. VAB means potential difference between A and B. Then the energy VAB into Q is given to the resistor, and this energy is received by the resistor is then converted into heat energy, and the temperature of resistor increases, and the power can be given by P is equal to electric power is equal to energy upon time required, which will be energy is VAB into Q upon T, and VAB into I means Q upon T. Q upon T is I, that is rate of flow of charge. Flow of charge is nothing but electric current, and that electric current we take here and we will get P is equal to VAB into I. Then by using this formula we can easily calculate electrical power of our bulb, electric bulb, which is placed or which is used in our home. The source of energy the cell gives in time t, the energy P into T to the resistor. If I is the current flowing continuously through the circuit, the heat produced in the resistor in time t will be given as H is equal to P into T is equal to VAB into I into T. According to Ohm's law, V is equal to IR, and therefore I is equal to V upon R. And if we replace I with V upon R, then we will get H is equal to V square into T upon R. And similarly, H can be given by using formula I is equal to V upon R. Here we use I is equal to V upon R and we get H is equal to V square upon R into T, or V square into T upon R. Similarly, if we use VAB is equal to IR, then we will get H is equal to I into R. Here I into R means V into T is equal to I square R T, and here H I square R T, H is equal to I square R T, is called Joule's law of heating. That means H, the heat produced, can be calculated by using formula V into I into T, or V square into T upon R, or I square into R into T. Unit of electrical power, P is equal to V into I, where V is potential difference, volt, and I is current, which is calculated in ampere, measured in ampere. Therefore, 1 volt into 1 ampere is equal to, but volt is nothing but joule upon coulomb, and ampere, that means current, is 1 coulomb upon 1 second, 1 coulomb per second, and therefore this 1 coulomb and this 1 coulomb gets cancelled, and we will get 1 joule per second, which is watt. This 1 joule per second is written as watt, and watt is a name of known scientist invented the power of steam. Steam power is invented by James Watt, and hence in the memory of James Watt, the unit of electrical power is given after his name Watt. Now we will move to heating effect of electric current. Here, to get heating effect of electric current, electrical conductor having higher resistivity are used. For example, a coil made up of an alloy nichrome, that means nickel and chromium, is used in the electric heater or cooker. Here electric cooker and heater is there, and coil is like a spring in a pen. The spring is there, and same structure is of coil, which is also known as solenoid type. While a tungsten wire is used in electric bulb, because of the current, this wire gets heated to nearly 3400 degrees Celsius and emits light, and the hot wire also radiates heat to a certain extent. Now let us see the structure of bulb. Electric bulb consists of a thin wire-like structure, but it is a solenoid type coil, and this coil made up of tungsten, and to increase its life it is kept in vacuum, and nitrogen gas is there to avoid more reaction due to high temperature, and there is a glass support below it, and this is overall structure of our bulb. Now the unit of electric power is 1 watt, but this unit is very small, hence we use 1000 watt or 1 kilowatt to measure electric power in practice. If 1 kilowatt power is used for 1 hour, it will mean 1 kilowatt into 1 hour of electrical energy, and 1 kilowatt used in 1 hour is nothing but 1 kilowatt hour is equal to 1 kilowatt into hour. 1 kilowatt means 1000 watt, and 1 hour means 3600 seconds. Therefore this will equal to 3.6 into 10 raised to 6 watt second, which is nothing but 3.6 into 10 raised to 6 joule, and this quantity is nothing but our 1 unit which is written on our electric bill. Now another example of heating effect of electric current is fuse wire. Now here is another example of heating effect of electric current. Several times we hear or read about a building catching fire due to short circuit. What is short circuit? Let us discuss about it. The home electrical connection consists of live, neutral and earth wires. The live and the neutral wires have potential difference 220 volt, and the earth is connected to ground. Due to a fault in the equipment or if the plastic coating on the live and the neutral wire gives away, the two wires gets connected. If the two wires gets connected, there will be a large flow of current producing large amount of heat, and if any inflammable material such as wood, cloth or plastic is present there, then it may catch fire. A fuse wire is used as a precautionary measure. We have learnt about fuse wire in previous standard. As soon as a high current flows in a circuit, the fuse wire melts and breaks the circuit and any mishap is avoided. Now, similarly, like a fuse wire, some miniature circuit breakers also use. Here in figure or in picture, the fuse is like this. This is also fuse, this is also fuse. These are all types of fuse, and here in this figure, miniature circuit breaker, which is also called as MCB, switches are used in homes. When the current in the circuit suddenly increases, this switch opens and current stops, and different types of MCBs are used. For the entire house, however, the usual fuse wire is used. That means fuse wire is also there in a house, and different types of MCBs are also there to avoid mishap due to short circuit. Now let us see some examples depending on heating effect of electric current. Example 1. A 6-meter long wire made from an alloy nichrome is shaped into a coil and given for producing heat. It has a resistance of 22 ohm. Can we get more heat if the wire is cut into half of its original length and shaped into a coil? For getting energy, the two ends of the wire are connected to a source with a potential difference of 220. Now here what is given? The resistance 22 ohm, potential difference 220 volt. Now if we use coil of whole wire, P is equal to V square upon R, where V is 220, R is 22, and we will get 220 square upon 22, and answer will be 2200 watts. Now let us consider half length wire. If coil of half length is made, then P is equal to V square upon R, which is equal to 220 square upon 11, which is 4400 watt. And by comparing the values of both the powers, we can say this means that more heat will be obtained after cutting the wire into half. That means if we cut the wire into half, we will get more energy. Now, second example, a cell is connected to a 9 ohm resistance, because of which heat of 400 joule is produced per second due to current flowing through it. Obtain the potential difference applied across the resistance. Now given, what is given? Heat at 400 joule per second. That means in 1 second heat produces 400 joule. Therefore 400 is equal to V square upon 9, where R, the value of R is 9 ohm. Therefore V square is equal to 400 into 9. If we take square root of 400 into 9, we will get 20 into 3, and the answer will be 60 volt. That means the potential difference applied across the resistance is 60 volt. Now here more examples are given. Let us go through it. An electrical iron uses a power of 1100 watt when set to higher temperature. If set to lower temperature, it uses 330 watt power. Find out the electric current and respective resistances for the two settings, the ion is connected to potential difference of 220 volt. हे आपलं घरातलंच एक्झाम्पल आहे. इथे आपल्याला आयन, इलेक्ट्रिक आयन मीन्स इस्त्री, त्याला जर आपण हाय पॉवर यूज केली म्हणजेच हायर टेम्परेचर घेतलं तर त्याला पॉवर 1100 वॅट लागते आणि लो टेम्परेचरवर सेट केलं तर पॉवर लागते 330 वॅट. आणि त्यासाठी आपल्याला पोटेन्शियल डिफरन्स जो आहे तो दिलेला आहे 220 volt. Now potential difference is 220 volt. Let us consider two powers A and B and we will find power is 1100, I1 is equal to P upon V is equal to 1100 upon 220. Therefore I1, the value of I1 is 5 ampere, and for 330 watt I2 will be equal to P upon V. Value of P is 330 upon 220 is equal to 1.5 ampere. Now by using these values, let us find the resistance. R1 is equal to V upon I1 is equal to 220 upon 5, which is 44 ohm, and for the resistance R2 for I2 1.5, we will get V upon I2 is equal to 220 upon 1.5, which is 146 ohm. That means for more power the resistance is less, and to apply low power, that means low temperature, we have to keep resistance high so that I2 will be lowered. Now fourth example, an electric tungsten bulb is connected into a home circuit. The home electric supply runs at 220 volt potential difference. When switched on, a current of 0.45 ampere flows through the bulb. What must be power wattage of the bulb if it is kept on for 10 hours? How many units of electricity will be consumed? हे सुद्धा आपल्या घरातलंच उदाहरण आहे. एक बल्ब आहे, जो बल्ब आपल्या घरात लावलेला आहे, त्याला सप्लाय आहे 220 वोल्ट आणि करंट त्यातून फ्लो होतं 0.45 एम्पियर. Now we have to find out the wattage of that bulb, and if this bulb is kept running for 10 hours, what will be the consumption of electricity? Let us see. Given is potential difference, that is 220 volt, current is 0.45. Therefore the power can be calculated by potential difference into current, that is 220 into 0.45, which is 99 watt. Therefore the bulb must be of power 99 watt. In 10 hours it will use 99 watt into 10 hours of electricity, which is 990 watt hour is nothing but 0.99 kilowatt hour, because we measure electricity in unit kilowatt hour. One unit is kilowatt, 1 kilowatt hour, and to convert watt hour into kilowatt hour we have to divide 990 by 1000 and we will get 0.99 kilowatt hour. Now here we have seen heating effect of electric current. आतापर्यंत हिटिंग इफेक्ट आपण इलेक्ट्रिक करंटचे पाहिले. आता आपल्याला पाहायचं आहे मॅग्नेटिक इफेक्ट ऑफ इलेक्ट्रिक करंट. आणि हे पहिल्यांदा कोणाला कळून आलं तर हे सायंटिस्ट आहेत हॅन्स क्रिश्चियन ओरस्टेड. ह्यांनी एक एक्सपेरिमेंट केला आणि ह्या एक्सपेरिमेंट मध्ये he has taken one wire, conducting wire, and which is connected to electric source of electricity, that is cell, and one magnetic needle is kept nearby it. आणि जेव्हा त्यांनी हा इलेक्ट्रिक सर्किट मधून सप्लाय स्टार्ट केला तेव्हा त्याला असं लक्षात आलं की इलेक्ट्रिक सर्किट सुरू केल्याबरोबर मॅग्नेटिक निडल मध्ये डिफ्लेक्शन आलं. त्याने हे प्रयोग अनेक वेळा केला. मग त्याने थोडासा बदल केला. ही हॅज चेंज द पोलॅरिटी ऑफ सेल. म्हणजे जिथे पॉझिटिव्ह आहे तिथे निगेटिव्ह लावलं आणि जिथे निगेटिव्ह आहे तिथे पॉझिटिव्ह लावलं आणि सेम एक्सपेरिमेंट कॅरी आउट केला. अँड ही फाउंड दॅट द डिफ्लेक्शन इज ऑन अदर साइड. आणि ह्यावरून एक्सपेरिमेंट त्याने अनेक वेळा केले आणि ह्यावरून त्याच्या लक्षात आलं की when there is a current carrying conducting wire, it produces magnetic field around it, and the direction of magnetic field depends on the direction of current. म्हणजेच करंटचं डायरेक्शन चेंज झालं की मॅग्नेटिक फील्डचं डायरेक्शन सुद्धा चेंज होते. आणि हे जे डायरेक्शन आहे हे डायरेक्शन फाइंड आउट करण्यासाठी त्याने आणखी एक एक्सपेरिमेंट केला. That experiment is current carrying wire is placed or is pierced through a cardboard, and on that cardboard he placed some iron fillings, and when he started the current he found that iron fillings gets arranged in concentric circle in the form of concentric circle. And he found or he observed another thing, that these concentric circles, as we move away from this wire, this concentric circle gets bigger and rarefied. Rarefied means the effect of magnetic field gets diminished, decreased. And if he increase the cell number of cell, म्हणजे power जर इलेक्ट्रिसिटी जर increase केली, then also as the intensity of electric field increases, intensity of magnetic field also increases. हे दोन महत्वाचे ऑब्झर्वेशन्स त्याला इथे मिळालेले आहेत की जर एखादी करंट कॅरिंग वायर असेल, कंडक्टिंग वायर असेल, त्याच्या भोवती जर आपण आयर्न फिलिंग्स अशा प्रकारे पसरवून ठेवले तर जेव्हा इलेक्ट्रिक करंट पास होतं त्यावेळेला कोसेंट्रिक सर्कल्स फॉर्म होतात आणि ते कोसेंट्रिक सर्कल जसं लांब जायचं तसं ते रेअर होत जातात, रेअरिफाय होतात. म्हणजेच मॅग्नेटिक फील्ड कमी होत जातं. आणि जर इंटेन्सिटी ऑफ इलेक्ट्रिक फील्ड वाढवली, इलेक्ट्रिक फील्ड वाढवलं तर इंटेन्सिटी ऑफ मॅग्नेटिक फील्ड सुद्धा वाढते. नाउ टू गेट द डायरेक्शन ऑफ मॅग्नेटिक फील्ड, one rule is taken into consideration. That rule is right hand thumb rule. Let us see what is that rule. Imagine that you have held the conductor in your right hand in such a way that your thumb points in the direction of current. Then turn your finger around the conductor like that. म्हणजेच करंट कॅरिंग वायर आहे त्याच्या भोवती आपण हात ठेवायचा अशा प्रकारे. अँड दिस थंब, आपल्या हाताचा अंगठा जो आहे तो इलेक्ट्रिक करंटचं डायरेक्शन दाखवत असेल तर त्या कंडक्टरच्या भोवती जो आपण बोट गुंडाळलेली आहे, बोट, दॅट फिंगर्स, डायरेक्शन ऑफ फिंगर्स विल शो मॅग्नेटिक लाईन ऑफ forces, direction of magnetic line of forces. In this case the direction is downward, and if we hold this conductor in such a way that this thumb will show downward direction, then obviously the fingers will show this direction, that is clockwise direction. And by using this right hand thumb rule we can find the direction of magnetic field. Now the magnetic field produced by current through a circular loop of a conducting wire. आतापर्यंत जी आपण वायर पाहिली होती ती सिंगल वायर होती. Now they have made some change and they form a loop. आणि असा लूप जर केला आणि त्याला जर आपण अशा प्रकारे सेल जोडलं आणि त्यातून इलेक्ट्रिसिटी जर पास होऊ दिली तर तिथे डायरेक्शन ऑफ मॅग्नेटिक फील्ड कशा प्रकारचं असेल तर by using right hand rule we can say at P the direction of magnetic field is anti-clockwise and direction of electricity is upward at P and here at Q it goes down and by using same thumb rule we get direction of magnetic field or line of forces as clockwise and due to this clockwise direction and this anti-clockwise direction here in this area we found that there is direction from S to N. That means it will form S pole, that means south pole, and this will form north pole and it acts as a magnet. This coil will act as a magnet. Now if we take more number of loops of same coil which we have seen earlier, आधीच आपण पाहिलेलं जे काही लूप होतं त्याला आणखी जर नंबर ऑफ लूप्स वाढवले तर आपल्याला एक स्प्रिंग फॉर्म झालेली दिसेल अँड दॅट स्प्रिंग इज नथिंग बट इट इज कॉल्ड एज सॉलेनॉइड. आणि जर सॉलेनॉइड मध्ये सुद्धा अशाच प्रकारे जर इलेक्ट्रिक करंट पास केलं तर आपल्याला अशा प्रकारचे लाईन ऑफ फोर्सेस दिसतील. हे आपल्याला आधी आपण पाहिलेल्या लाईन ऑफ फोर्सेस सारख्याच दिसतात. हे आपण मागच्या स्टँडर्ड्स मध्ये पाहिलेल्या आहेत की एखादा बार मॅग्नेट जर ठेवलं तर त्याच्या भोवती जे मॅग्नेटिक फील्ड तयार होते ते सेम मॅग्नेटिक फील्ड इथे या सॉलेनॉइड मुळे सुद्धा तयार होते. द प्रॉपर्टीज ऑफ द मॅग्नेटिक फील्ड ऑफ अ सॉलेनॉइड are very similar to the magnetic field produced by a bar magnet. One of the open end of a solenoid acts as a magnetic north pole and the other as the magnetic south pole. The magnetic line of force inside the solenoid are parallel to each other. Here you will see the magnetic line of force are parallel to each other. Now, as there is a magnetic line of forces and there is a conductor, there must be a force acting on current carrying conductor in a magnetic field. If we place a magnet nearby this current carrying conductor, then it will experience a फोर्स. कारण ही जी तार आहे ही सुद्धा एक मॅग्नेट बनणार आणि त्याच्याजवळ जर आणखी एक मॅग्नेट नेलं तर त्याच्यामुळे सुद्धा काय होणार आहे त्याच्यामध्ये फोर्स ऍक्ट होणार अँड दॅट फोर्स कॅन बी शोन बाय युजिंग दिस एक्सपेरिमेंट. इथे एक तार लावलेली आहे, इथे एक हॉर्शू मॅग्नेट आहे अँड इफ वी पास इलेक्ट्रिसिटी थ्रू दिस कंडक्टर इट एक्सपिरियन्सेस अ force and that force depend on the direction of magnetic field and the direction of magnetic field depends on direction of current. Therefore, as we change the polarity, the direction of magnetic field will change and the force applied or force experienced by this wire will also change. That means the experiment clearly shows that a force is exerted on the current carrying conductor. The direction of this force depends on both the direction of the current and the direction of the magnetic field. Now, to get the direction of the force, that means the force experienced by conductor, we use Fleming's left hand rule. What is that? According to Fleming's left hand rule, the left hand thumb, index finger and the middle finger are stretched so that to be perpendicular to each other. If index finger is in the direction of the magnetic field, the middle finger points in the direction of current, then the direction of thumb is the direction of the force on the conductor. That means जर middle finger हे डायरेक्शन ऑफ करंट दाखवत असेल, इंडेक्स फिंगर म्हणजे तर्जनी द डायरेक्शन ऑफ मॅग्नेटिक फील्ड दाखवत असेल, तर ड्यू टू these two magnetic field and current, the force experienced by the conductor is in the direction of thumb.